Imagine a world where machines can comprehend complex patterns, understand speech, recognize images, and even drive cars. A world where artificial intelligence isn't just a concept, but a transformative reality. Welcome to the age of deep learning. Deep learning, a subset of machine learning and artificial intelligence, is an intriguing field that's rapidly transforming our lives and the industries around us. It's a technology that's paving the way for innovation and progress in a multitude of sectors, from healthcare to transportation, from technology to entertainment and beyond. But what exactly is deep learning? Well, to put it simply, it's a type of artificial intelligence that's inspired by the human brain. It's based on something called artificial neural networks, or ANNs, which are designed to mimic the way our brains process information. Just think about it. Our brain, a 3-pound mass of gray matter, is an incredible processing powerhouse, capable of interpreting and responding to an array of complex stimuli. In a similar vein, ANNs are designed to comprehend and learn from complex patterns and data structures, much like our brain does. But of course, the human brain is a highly intricate organ, and replicating its functions is no small feat. That's where deep learning comes into play. Deep learning involves creating multiple layers within these artificial neural networks, each of which learns and processes a different aspect of the data. It's these layers that give depth to deep learning, allowing it to understand and interpret complex patterns and data structures. Fascinating, isn't it? The way deep learning is revolutionizing our world is just the tip of the iceberg. But before we dive deeper, subscribe to our channel, hit the like button, and stay tuned for more intriguing insights. Because trust me, you don't want to miss what's coming up next. Just like the human brain, deep learning operates on a network of neurons. But what exactly are these neurons, and how do they function in an artificial neural network? Imagine a system that works like a human brain. It learns, adapts, and processes complex information. It's called an artificial neural network, or ANN for short, and it's the foundation of deep learning. An ANN consists of layers upon layers of individual processing units, also known as neurons. Now let's break down how these neurons function. Each neuron receives input, like the sensory input our brain cells receive. This input is then processed using a mathematical operation similar to how our brain processes information. The result? An output, which is passed on to other neurons in the network. But there's more to it. These neurons don't just passively receive and transmit information. They learn and adapt. As the ANN is fed more and more data, each neuron adjusts its operations based on the errors it makes. This process, called backpropagation, is akin to how our brain cells learn from experience and mistakes. The beauty of this system lies in its interconnectedness. Each neuron in an ANN is connected to many others, forming a dense network. This network allows the ANN to process complex, multidimensional information, much like our brain does. The interconnectedness also allows the system to learn complex patterns and make sophisticated predictions. For instance, it can recognize a cat in an image, understand spoken words, or even drive a car, tasks that are simple for us humans, but incredibly challenging for traditional algorithms. So, when we say deep learning, we're not just talking about machines learning, we're talking about machines learning deeply, understanding complex patterns, and adapting to new information just like us humans. Deep learning, thus, is not just about machines learning, but about them learning deeply, just like us humans. The deep in deep learning isn't there just for the show. It signifies the depth of layers in a deep neural network. But why does this depth matter? Well, let's dive in to understand. When we talk about the depth in deep learning, we're referring to the number of layers within a deep neural network. Each layer in this network is a level of abstraction. The more layers a network has, the more abstract the concepts it can understand. Imagine this as a multi-story building. The first floor, or the first layer, might identify simple patterns, such as lines and edges in an image. As you move up the floors or layers, the network begins to recognize more complex patterns. By the time you reach the top floor, the network can identify intricate patterns, like a human face in an image, or even the sentiment behind a sentence. But how does this work? Well, every layer of the network learns from the previous layer. Each layer takes the output from the layer before it, applies some transformations, and passes it on to the next. The transformations are based on weights, which are adjusted during the training process. This is how a deep neural network learns and adapts. The beauty of a deep neural network is in its versatility. The same network can learn to recognize both cats and dogs, or even translate languages, given the right training data. The key is in the depth of layers that enable the network to interpret and understand the intricacy of the data. So the depth in deep learning is not just a fancy term. It's the essence of how deep learning models function. The depth allows these models to understand complex patterns and make sense of the world around us in a way that simpler models can't. The depth in deep learning, thus, is the key to unlocking complex patterns and understanding intricate data. Deep learning and machine learning often get used interchangeably. But are they the same? Not quite. Let's dig into the differences. Machine learning at its core is a method of data analysis. It's a way for computers to learn from experience, much like we humans do. A machine learning algorithm learns from a set of data, finds patterns, and then applies those patterns to new data to make predictions or decisions. But deep learning takes this concept to a new level. It's a subset of machine learning inspired by the structure and function of the human brain, specifically the idea of interconnected neural networks. Deep learning algorithms use artificial neural networks with multiple layers. These are our deep neural networks. Each layer of neurons learns to recognize different features of the input data, and each successive layer uses the output from the previous one as its input. So, what does this mean in practice? Well, deep learning can handle vast amounts of data and learn complex patterns, something that traditional machine learning techniques might struggle with. Because of its ability to learn from unstructured and unlabeled data, deep learning outperforms machine learning in tasks like image and speech recognition. It's like giving the machine a supercharged brain. But it's not all roses. Deep learning requires a lot more computational power and data than traditional machine learning. And while machine learning models are often easier to understand and interpret, deep learning models can be a bit of a black box. We don't always know why they're making the decisions they are. So, while deep learning and machine learning do share some characteristics, they're not the same. They each have their strengths and weaknesses, and their uses depend on the problem at hand. Deep learning, therefore, is not just another form of machine learning, it's a quantum leap forward. Deep learning may seem like a complex concept, but its applications are all around us. It's the magic behind many of the technological marvels we take for granted today. Let's delve into some of these amazing applications. First up, image recognition. Have you ever wondered how your smartphone camera automatically identifies faces or scenic views? That's deep learning at work. Using layers upon layers of artificial neurons, deep learning algorithms can identify patterns in visual data, enabling them to recognize and categorize images with remarkable accuracy. The applications are vast, from aiding medical diagnostics by identifying anomalies in X-rays to powering the facial recognition security systems in our devices. Next, let's talk about speech understanding. Ever asked Siri, Alexa, or Google Assistant a question? The reason these virtual assistants can understand and respond to your queries is because of deep learning. These systems use deep learning algorithms to process and interpret the spoken language, making our interactions with technology more natural and intuitive. Last but not least, autonomous vehicles. The dream of self-driving cars has been brought closer to reality thanks to deep learning. These vehicles are equipped with numerous sensors that constantly feed data into a deep learning system. This system then processes the data in real time, enabling the vehicle to recognize objects, interpret road signs, and make split-second decisions, all without a human at the wheel. These are just a few examples of how deep learning is revolutionizing our world. From healthcare to entertainment, transportation to personal technology, deep learning is being used to solve complex problems, improve efficiency, and create incredible new possibilities. Deep learning is not just transforming our industries, it's changing our lives. If you enjoyed this journey into the depths of deep learning, remember to subscribe, like this video, and leave us a comment by typing, "I have subscribed to the channel." Let's continue exploring the fascinating world of artificial intelligence together.